The air is thick with dust and the metallic tang of fear. From atop the crenellated walls of a besieged city, defenders peer out into a sea of banners, the enemy encamped in endless rows across the plain. Drums pound in rhythmic unison, each strike vibrating through the stone beneath their feet. Far below, siege towers creep forward like giant lumbering beasts, their hides of wet leather glistening under the sun to resist flaming arrows. But on the battlements, something stirs, something the attackers have never seen before. 3 great wooden arms rise side by side, their lengths bound in tightly twisted ropes of sinew, glistening with animal fat to keep them supple. They creak and groan under the strain as crews heave at windlasses, pulling them back against the coiled power hidden in their frames. This is no ordinary catapult. This is a monster with 3 throats, ready to roar. The commander of the city's garrison, his armor dulled by weeks of dust and ash, raises his arm. The crews tense. With a shouted order, 3 massive projectiles, stones the size of a man's head, are released in perfect synchrony. They arc into the air like a flock of birds in deadly formation before plunging into the enemy ranks. The first smashes through the roof of a siege tower, splintering timbers. The second strikes a knot of soldiers, scattering bodies and shields like leaves in a storm. The third hits the earth with such force that it kicks up a geyser of dirt, momentarily blinding the advancing troops. Panic ripples through the attackers. From the safety of the wall, the defenders cheer, their morale surging. Below, the enemy falters, not from the damage alone, but from the shock of an unfamiliar weapon tearing through their disciplined advance. In warfare, the unknown is as deadly as the blade. And this 3-barreled catapult, is the unknown given form. The mystery in history. What makes this moment remarkable is not simply the destruction it wrought, but the fact that most people today have never heard of such a machine. Ancient Chinese warfare is often remembered for its disciplined armies, the Great Wall, and legendary strategists like Sun Tzu. Yet within the vast scroll of China's military history lies a near-forgotten chapter, the creation of a siege engine unlike anything used in the West at the time, a triple-armed catapult that could unleash a volley with unprecedented speed. How did it come to be? Why was it built? And perhaps most puzzling of all, why did it disappear from the battlefield so quickly, leaving only scattered references in ancient texts and faint hints in archaeological records? A land torn by endless war. To understand, we must step back into the Warring States period, a time when China was not a single unified empire, but a patchwork of rival kingdoms, each striving for supremacy. The Zhou dynasty's central authority had crumbled, and from the 5th century BCE to the unification under Qin in 221 BCE, the land was consumed by a brutal, centuries-long competition for dominance. In this crucible of war, innovation was not optional, it was survival. Kingdoms poured resources into military engineering, seeking any advantage over their neighbors. The invention of the crossbow, advancements in metallurgy, and refined logistics systems all emerged during this era. Siege warfare became an art in itself. Armies needed to overcome massive walls, moats, and fortified gates, while defenders sought ever more ingenious ways to keep them at bay. The 3-barreled catapult was a child of this environment, born from desperation, ambition, and the restless ingenuity of Chinese military engineers. The shadow of the West. At this point in history, the Mediterranean world had its own siege machines, torsion-powered ballistae, stone throwers, and later the Roman onager. But China's designs evolved largely independently, guided by their own engineering traditions. Unlike the torsion frames of Greece, Chinese engineers often relied on counterweights, traction power, and a unique mastery of composite materials like twisted sinew and layered bamboo. And then came the leap. Why settle for one firing arm when you could have 3? This was not simply about increasing destructive power. It was about rhythm, about overwhelming the enemy with rapid successive strikes before they could regroup. By the time they recovered from the first impact, the second and third were already in flight. Foreshadowing the legend. The records are sparse, but what they reveal is tantalizing. Some military treatises, rare survivors of the Warring States' intellectual firestorm, hint at siege devices with multiple arms or triple jaws, capable of launching several projectiles in close succession. Whether these descriptions refer to our three-barreled catapult or to something else entirely is debated, but the imagery is too compelling to ignore. It is this mystery that drives historians and engineers alike to reconstruct the possible form and function of such a weapon. And for us, it serves as the perfect entry point into a story that is as much about human ingenuity as it is about war. The stakes of innovation in the Warring States period, the cost of military failure was absolute. A breached wall meant slaughter, enslavement, or the erasure of a city's name from the records. For the ruling elites, a new weapon could mean the difference between dynastic survival and obliteration. For the engineers who built it, success promised wealth and honor, failure could mean exile, or worse. Imagine the pressure on the teams constructing that first prototype. Every rope twist, every carved beam was a gamble. The balance had to be perfect. The alignment of the arms had to ensure simultaneous release, or else the weapon would tear itself apart, all under the watchful eyes of generals and rulers who knew their lives hung in the balance. Into the heart of the story, and so, with the image of that first triple volley still echoing in our minds, we begin our journey, how ancient China built a war machine that could dominate a battlefield, how it worked, why it mattered, and why it slipped into obscurity. The answers lie not just in dusty manuscripts or scattered archaeological fragments, but in the heartbeat of a civilization that turned survival into art, and war into a proving ground for genius. Next, we step into the workshops and forges where this improbable machine took shape, where invention met necessity, and history was written in wood, rope, and stone. The echo of that first triple volley fades, but the road to its creation began centuries before the siege where it made its mark. To understand this war machine, we must journey backward, through generations of blood-soaked fields, shifting alliances, and the relentless arms race that defined China's Warring States period. The furnace of rivalry. By the 5th century BCE, China was fractured into 7 dominant kingdoms: Qi, Chu, Yan, Han, Zhao, Wei, and Qin, each locked in a brutal struggle for supremacy. These were not skirmishes over petty borders, they were existential conflicts, where the fall of a capital meant the absorption, or annihilation, of an entire state. Every kingdom knew that a moment of military stagnation was an invitation to invasion. This environment birthed a feverish competition in military innovation. No invention was too costly if it could deliver a decisive advantage. Armies experimented with heavy chariots, crossbows of unprecedented power, and complex signaling systems using flags and smoke. Siegecraft, once a secondary skill, became a central military science. The early siege-problem city walls were the ultimate defense in ancient China. They were vast, engineered with tamped earth cores, brick facings, and defensive walkways. Taking such fortifications required more than ladders and brute force, it demanded machines that could break walls, destroy gates, or clear defenders from the parapets. The earliest siege engines in China were traction trebuchets, simple frames with long arms swung by teams of men pulling ropes. They could hurl stones or fire pots, but their firing rate was slow and their range limited. In the heat of battle, every wasted moment allowed defenders to regroup. By the mid-Warring States era, engineers began to push beyond these limitations, studying how to increase rate of fire, accuracy, and destructive force all at once. The spark of an idea. One story, preserved in fragments within later military treatises, tells of an unnamed engineer in the state of Wei. Watching a traction trebuchet fire, he noted the dead time between launches, the moment when the weapon was being reset while defenders rained arrows down on its crew. What if, he wondered, there were multiple arms ready to fire in sequence without pause? The concept was radical. Most siege engines of the day were massive, single-purpose constructions. Adding multiple throwing arms meant reimagining the frame's strength, synchronization, and balance. But the pressure to innovate was relentless. Wei's borders were threatened by Qin's rising power, and a breakthrough weapon could tilt the balance. Patronage and pressure. Innovation in the Warring States wasn't driven by lone inventors working in isolation, it was a state-sponsored endeavor. Rulers maintained dedicated workshops where artisans, blacksmiths, and engineers worked under military oversight. Successful inventors could be rewarded with land, titles, or exemption from military service. Failure, however, could lead to disgrace or execution. In such a climate, ideas like the three-armed catapult were gambles with high stakes. The ruler's patronage meant access to the finest timber from the southern forests, sinew from hunting expeditions, and metal fittings forged in royal smithies. But it also meant the eyes of the court were always watching, expecting results. Philosophy meets engineering. Chinese military thought, captured in works like The Art of War, emphasized speed, deception, and overwhelming force. A weapon that could unleash 3 shots in rapid succession fit neatly into this doctrine. If the first volley disoriented the enemy, the second and third could break them before they recovered. It was not just about throwing rocks, it was about psychological dominance. Siege warfare was as much a battle of morale as it was of stone and steel. A triple-armed engine was not only a tool of destruction, it was a statement: we can strike faster than you can defend. The leap toward reality with concept and philosophy aligned, the challenge became one of mechanics. How could 3 arms be mounted without interfering with each other's swing? How could they be reloaded quickly enough to justify the added complexity? And most critically, how could the frame withstand the stress of 3 simultaneous launches without splintering under the strain? These questions would take us into the workshops where the first prototypes were born, where sawdust mixed with iron shavings and the air smelled of resin and sweat. And it is there, in the clanging forges and the shadowed beams of construction halls, that the 3-barreled catapult began to take form, a blend of engineering audacity and battlefield necessity. The workshop is dimly lit, the only light spilling in from narrow slits high in the wall. The air is heavy with the smell of pine resin, fresh-cut timber, and the faint tang of molten metal. In the center of the hall stands a skeleton of timber, massive beams joined by mortise and tenon joints, lashed and pegged with wooden dowels the size of a man's arm. This is the birth of the 3-barreled catapult, not yet clothed in rope or armed with stone, but already towering like the frame of some wooden beast. The frame, strength and silence. The backbone of the machine is a rectangular chassis built from elm and Chinese fir, selected for a perfect balance of strength and flexibility. Elm resists warping under tension, while fir absorbs shock without splintering, essential when the whole structure is meant to survive repeated violent recoil. The base sits on wide, squat legs braced with diagonal supports, each pegged tight with wedges that can be replaced if they loosen after prolonged use. The engineers know one truth: the frame must never groan or shift when all 3 arms release. If it flexes, accuracy dies. If it cracks, lives are lost. The arms, 3 throats of thunder mounted atop the frame, are the weapon's defining feature, 3 throwing arms side by side. Each is carved from a single trunk of dense hardwood, polished smooth where it pivots on the axle. The arms are not perfectly identical, the outer 2 are angled slightly outward to avoid collision mid-swing, while the central arm rises just a fraction higher to give its projectile a cleaner arc over the others. Here lies the genius of the design: instead of 1 shot, the crew can unleash 3 at once, or fire them in rapid sequence, keeping a constant rain of stone on the enemy. The power source, twisted muscle. The heart of the machine's power lies in torsion bundles, thick ropes made of animal sinew and raw silk, twisted until they hum with stored energy. Silk gives flexibility and resilience, sinew adds brute strength. The bundles are kept under constant tension, their strands glistening with tallow to protect them from moisture and friction. Each arm has its own torsion bundle, housed in a reinforced wooden box, the ends of the arm running through the coils like an axle through a spring. By rotating the bundle with a windlass, the crew stores massive potential energy, waiting to be unleashed. The firing system, precision under pressure. A triple firing mechanism links the arms to a central release bar. Pulling a single lever can drop all 3 in unison, or individual pulls can be triggered to stagger the launches. The choice depends on tactics: overwhelming shock in 1 instant, or relentless pressure over several heartbeats. The trigger system is lined with bronze fittings to prevent wear and to ensure that, even under the strain of battle, there is no hesitation when the lever is thrown. A weapon of both science and theater. Beyond its mechanical brilliance, the weapon is designed to look terrifying. The triple arms rising into the sky, the glint of sinew ropes, the groan and snap as they fire, It is as much a psychological weapon as a physical one. For defenders on the wall, it is a guardian, for attackers below, it is a herald of death. The machine is ready. The crews, trained to load and fire in near-perfect rhythm, stand by. Outside, the enemy gathers. Soon, the catapult will leave the safety of the workshop for its first true test, where wood, rope, and stone will prove whether human ingenuity can alter the course of war. The morning mist clings to the city walls like a shroud. From the parapets, sentries squint into the distance, black dots move across the pale horizon, swelling into the shapes of banners, armor, and war drums. The enemy has come. Their siege towers roll forward on creaking axles, ladders and rams carried by lines of grim-faced soldiers. At the heart of the defenders' line stands the new war machine. Its triple arms are cocked and ready, their sinew bundles taut, the torsion ropes humming softly in the morning chill. This is the three-barreled catapult's trial by fire. The calm before the storm. The commander, an older general with scars carved into his cheeks, walks the length of the wall. His men bow slightly as he passes, not in ceremony, but in acknowledgement. They've heard the rumors of this machine, but today they will see if it lives up to its whispered legend. Below, the enemy drums pound in a slow, steady rhythm. It is a sound meant to unnerve, to synchronize the advance of thousands of feet. Siege towers edge closer, their hides of wet leather meant to resist flame. Archers begin to take positions, aiming at the walls. First blood. The general raises his arm. The crews move like a single organism, 3 teams, 1 for each arm, working in perfect unison. The first volley is loaded, 3 round stones, each weighing nearly 40 kilograms, heaved into the slings. The release levers are drawn back. The triple arms bend, groan, and strain against their bindings. The general's hand drops. A deafening crack splits the air as all 3 arms release in perfect synchrony. The projectiles arc high and fast, vanishing into the mist before smashing into the advancing troops. One stone caves in the roof of a siege tower, sending splinters and men spilling into the ground below. Another strikes a tightly packed formation, scattering shields and limbs in a burst of chaos. The third slams into the earth just short of the enemy line, showering them with dirt and shrapnel. The attackers falter, not from casualties alone, but from shock. They've never seen a war engine strike like this before. The rhythm of war. The genius of the design now comes alive. While one team reloads, the other 2 fire in staggered succession. A stone crashes into the base of a ram, shattering its frame. Another projectile smashes the leading edge of a siege tower, leaving it lurching to one side. Every few heartbeats, the walls roar with another shot. The air between the walls and the enemy is thick with flying stone. The attackers push forward, but their formations are breaking. Archers try to target the crews, but the parapets shield them well. The counterattack. The enemy adapts quickly. Shields are raised, and troops with thick wooden mantlets advance under cover. Engineers rush to construct protective screens for their siege towers. A group of archers moves into a flanking position, loosing arrows high into the air to rain down on the defenders. A cry goes up on the wall, a torsion rope on one of the outer arms begins to fray under the relentless strain. The crews work desperately to replace it while the other 2 arms continue to fire. The general knows this is the danger. If the machine breaks here, it could cost them the wall. Turning the tide with the repaired arm reloaded, the catapult unleashes another synchronized triple volley. This time all 3 projectiles are aimed at a single target, the lead siege tower. The first stone punches a hole through its side. The second smashes its will assembly. And the third collapses the tower entirely in a groaning crash of splintered wood and falling men. A roar erupts from the defenders. The enemy, seeing their most powerful siege engine destroyed, begins to withdraw under a hail of stones and arrows. The triple-armed monster has held the line. The first victory. When the last of the attackers vanish into the tree-lean, the crews lean against the battlements, exhausted but alive. The general walks to the machine, resting his hand on the central arm as though thanking it personally. This victory will be remembered, not just for the defense of the city, but for the day the three-barreled catapult proved itself in battle. But as history will show, every new weapon is a double-edged sword. The more it is used, the more the enemy learns to counter it, and the seeds of its eventual decline are already being sown. The victory at the city walls echoed far beyond the battlefield. Messengers carried word of the three-barreled catapult to allied courts and rival kingdoms alike. Some dismissed it as a novelty, an unproven trick. Others feared it was a harbinger of a new age of siege warfare. But for the state that owned it, the machine became both a military asset and a symbol of technological supremacy. The peak of its power in the years that followed its debut, the catapult appeared in multiple campaigns. Chronicles from the state of Wei and Zhao describe how these triple-armed engines shattered siege towers, breached outer fortifications, and even disrupted enemy camp defenses before a battle began. Commanders learned to use them not merely as defensive tools, but as psychological weapons, rolling them out into the open during battlefield confrontations to intimidate opponents before the first arrow flew. The sight of three great arms rising in unison, ropes humming like the strings of a colossal war harp, sent a shiver through enemy ranks. Some states tried to replicate the design. A few succeeded in building functional copies, but these lacked the precision craftsmanship of the originals. Without meticulous balancing and high-quality materials, the triple-armed frame would crack under strain or lose accuracy after only a few volleys. The hidden costs. Despite its success, the weapon carried burdens. First was the logistical strain. Moving a three-barreled catapult required dozens of oxen or teams of men, especially when traversing the uneven, muddy terrain common in China's river valleys. Its sheer size made it difficult to conceal during marches, and its complex assembly meant it could not be hastily deployed like smaller traction trebuchets. Then came the maintenance challenge. The sinew ropes needed to be kept dry and oiled, the wooden arms protected from warping in the humid summers. Replacing worn parts was costly, certain components required the skill of specialized artisans, and in wartime such craftsmen were in short supply. The enemy adapts. The greatest threat to the catapult's dominance came not from within but from without, the enemy learned. Siege tower designs evolved to incorporate angled armor and layered wet hides to absorb or deflect incoming projectiles. Troops advanced under mobile mantlets reinforced with earth and sandbags, blunting the psychological and physical impact of triple volleys. Moreover, new counter-siege tactics emerged: night raids to destroy siege engines before dawn, targeted volleys of incendiary arrows to ignite their wooden frames, and even the use of decoy formations to bait the machine into wasting ammunition. A fading roar. By the late Warring States period, warfare was shifting. Counterweight trebuchets, more compact and capable of greater range, began appearing, possibly influenced by cross-cultural exchanges along the Silk Road. Armies favored mobility over stationary power, and the massive triple-armed catapult became an increasingly rare sight. Its decline was not a sudden collapse, but a slow fading. One by one the machines were dismantled for parts, their beams repurposed for bridges, their sinew ropes salvaged for other weapons. A few may have been left to rot in the corners of abandoned fortresses, their once proud frames sagging under the weight of forgotten glory. Yet even in obscurity, its legend persisted, a whispered reminder of a time when the roar of three arms could decide the fate of a city. The battlefield where the three-barreled catapult once roared is silent now. The walls it defended have long since crumbled, their stones carted away to build new cities, new dreams. The names of the generals who commanded it have faded from records, and the engineers who designed it are ghosts in history, remembered only in fragments of text and scattered archaeological hints. Echoes in later machines. Though the weapon itself vanished, its spirit lived on in unexpected ways. Elements of its design, the synchronization of multiple arms, the emphasis on sustained volleys, found echoes in later siege technologies. Certain Song Dynasty trebuchets, centuries later, incorporated rapid-fire principles that may have drawn on distant memories of multi-armed devices. Even beyond China, parallels appear in medieval European and Middle Eastern war engines, though whether these were independent innovations or faint reflections carried along trade routes remains a tantalizing question. Its influence is subtle, like the trace of a brushstroke beneath layers of paint. You may not see it unless you know where to look, but once found, it changes how you see the whole picture. Why it was forgotten. History is selective in what it remembers. The triple-armed catapult's disappearance was as much about timing as it was about technology. As the Qin unification swept through the warring states, the focus shifted to more mobile warfare and mass-standardized equipment. Siege weapons became simpler, easier to produce and maintain. Complex marvels like the three-barreled design were sidelined, their blueprints, if they ever existed, left to decay. Without written schematics, without physical remains, it became a footnote in military chronicles, a curiosity to be mentioned, then passed over. The final reflection, and yet, for one brief chapter, it was the terror of the battlefield. It stood as proof of human ingenuity, of how far necessity can drive invention, and of the delicate balance between brilliance and practicality. The triple volley was more than a feat of engineering, it was a heartbeat of defiance, a thunderclap that told enemies, "We will not fall today." The roar is gone now, but perhaps that is fitting. Some machines are meant to live forever in the imagination, not in the museum. And so the three-barreled catapult remains, half history, half legend, its story waiting to be rediscovered by those willing to look into the forgotten corners of the past.